Hey, good morning, everyone. Good morning, Kevin. Good evening. I'm sure you're in
Hi,
China, I think.
hello, Ricardo. Yeah, I mean in China, so it's evening now. Yeah.
Good evening for you.
Hi,
Yeah.
Nikita.
Hey, Karen.
Yeah, I'm trying to make my slide public available. Hold on a second.
We'll start maybe in a couple of minutes. I'm not really sure if any other people are going to join. In any case, I posted the link to our meeting notes, and you can go ahead and add yourself as an attendee.
Okay.
Yeah,
Hi,
let me-
okay.
So
Nikita, you're back from vacation.
Yeah, yesterday was actually like a public holiday, so not really a
Oh,
vacation,
got
but
it.
just
Got it.
out.
Nice.
all right. So let me share the screen. Okay, and we can start.
Sounds good.
Okay. Is it showing? Yeah.
Yep.
Yes.
Okay. All right. It's great to be here introducing the Karmada Project updates. So actually, the Karmada Project was accepted by CNCF TOC to the sandbox last year, and recently we already started the application to enter the incubation. So I just want to share the updates about the project and also its community. All right, so a little bit background of the project. So we know that the multi-cluster, multi-cloud, it's now the kind of the most use case of the enterprises. Yeah, so a lot of people are trying to manage to improve the management efficiency among the multiple clusters across public cloud, private cloud, and also the different data center. And we observed that actually there are a lot of challenges the people are facing day to day. For example, we know that there are a lot of clusters resulting to the fragmented API endpoint, right? People have to switch between kube configs to enter the different cluster, and also it's kind of repetitive setting up new clusters. And actually, we know that the different managed Kubernetes service by the different cloud provider provides their own cluster lifecycle API. Although the cluster API project is trying to mitigate this situation, and also from the application perspective, the application management have to be kind of divided by the different clusters, and the people are suffering from managing the kind of different configuration, different version of the different part of the application in different clusters, and also they also want to kind of sync the application status or versions, for example, to do a canary rollout among the clusters. And also for the availability, we know that especially Kubernetes itself, the cluster are often regarded as a kind of failure domain by a lot of end users, right? For example, if one of the cluster uses kind of the remote storage, any crash of the storage would result in the whole cluster being unavailable, right? And also in the earlier days, there are a lot of kind of multi-cluster, multi-cloud product resulting vendor locking. So that's why we started the Karmada project. And also actually as a continuation of the Federation, Kubernetes Federation V1 and V2, we found out the Kubernetes native API support is very important for people managing their workloads across the clusters. People don't want spend their time adopting a new dedicated set of API for multi-cluster, especially they have kind of other business system on top of Kubernetes already. They don't want spend more effort to migrate to a dedicated multi-cloud architecture. So that's one of the major point we want to deal with. And also the Karmada project, we think that the multi-cluster scheduling is very important to the end users. And also we want to provide a kind of out-of-box functionalities for the users, especially to help them achieve the active mode or a remote disaster recovery mode for their application, to avoid their kind of learning efforts of adopting to the multi-cloud architecture. Yeah, and also in the earlier days, we know that the managing clusters in different network environment is kind of very important to people. Some people have their the management plan in private cloud or in data center, but their Kubernetes clusters on the in the public cloud. But some users have the totally reverse situation. So we're trying to provide the unified cluster management to deal with the networking issue. So the key architecture of the Karmada project, it looks like quite similar to the Kubernetes single cluster architecture today. Karmada itself has its own API server. Actually, we directly reuse the binary of the Kubernetes API server, so it's quite easy to expose what we have now already, the Kubernetes native APIs. And for the multi-cluster specific functionalities, we expose the Karmada policies to help users define that. And also for the underlying cluster management, we actually have a special design for the object synchronization. So it's actually a namespace per cluster, but we call it the execution space. So every cluster will access its own dedicated namespace for synchronizing all the objects they are care about. And we support a different mode of the management, so we can have the centralized mode. So basically, all the clusters are directly managed by the control plane. This is very suitable for the clusters in the public cloud, and also we support the agent mode, which is quite similar to the kubelet list watching the API server. Yeah, so the Karmada agent will list watch the Karmada API server to synchronize and update the all the objects that need to be deployed or applied to the member clusters. And
so for the APIs, the Karmada API server, do you actually keep it in sync with the Kubernetes API? Is it always released when there's a new Kubernetes API server released, or
so currently we are kind of so one minor release behind the upstream Kubernetes. Yeah, but actually it's not the version is not that critical. Actually, users are able to use the older version of the Kubernetes API server as the Karmada API server.
Yeah, makes sense. Yeah, there are some like cloud services too that don't have the latest Kubernetes API server or the latest Kubernetes version, like GKE or EKS. Another question with the private cloud, when you have a Karmada agent, that agent actually, it's an outgoing, like the API calls are basically outgoing, right? They're not incoming like in the other
right.
case.
So in the private cloud, it's like if the clusters we configure the SNet, so we don't need to expose the API server of the member cluster to the internet, and we can still make it managed by the whole control plane.
That makes sense. Yeah, thanks.
Just a quick question. So is the Karmada API server an aggregated API server, or how does it work?
We actually have the aggregated API server also to provide more functionalities, but for the Kubernetes API native APIs and the Karmada policies, we actually directly use the Kubernetes API server binary. So the Karmada policies are like the CRDs installed in a normal Kubernetes API server. Yeah.
Okay, got it. Thanks.
Actually, the workload controllers and the scheduler are kind of very different to the single cluster one. So we know that there are a lot of native APIs. For example, the deployment state of set, also services configs, and also the config relevant things. But we don't need to provide the exactly the same behavior in the Karmada control plane, because what we do is like we compute and schedule to decide which clusters need these objects. So the workload controller here is kind of actually the API kind of agnostic logic to deal with that. And also the Karmada scheduler here is mainly for scheduling the resources that have different resource requirement. You know that, for example, the config map is kind of just need some storage for the kind of metadata, right? But the deployment or state of set, they need the actual CPU and the memory from the member cluster. So the Karmada scheduler will deal with that, taking the cluster's resource availability and also the cluster's status into consideration.
So I have a question, if you don't mind. So the model is push or pull from Karmada API, like the master, or like the API server to the member clusters. Is it push or pull?
So we support both. Yeah. So
okay.
It's if you are familiar with the Kubernetes Federation, the execution controller one is kind of the push mode. Every synchronization is kind of triggered by the Karmada control plan, and the pull mode is like the every time the synchronization is triggered by the Karmada agent. Yeah.
Okay. So just in the public API, which is the execution controller, you're using the push mode, but otherwise it's pull mode. Okay. Another question about the scheduler, if you don't mind. So is it like a whole, like a secondary scheduler for Kubernetes, right? It's not like a plugin. So, or it's just a plugin, so I can use whatever any other scheduler plugin I want with Karmada.
So yeah, actually, the scheduler is kind of required one because we need to have the scheduler to deal with which object goes to which cluster, but users are able to replace this scheduler with their own, and also we have the scheduler name mechanism, which is quite similar to the mechanism we have in the upstream Kubernetes. So basically, users are also able to have multiple Karmada scheduler implementation running inside the one platform. Yeah, inside the one the Karmada deployment.
Okay, thank you.
Okay. Yeah. So here is the core concepts of the Karmada, which also helps help you understand the whole mechanism. So the resource template is kind of what people input or submit to the Karmada API server, especially when people deploying their applications, they can directly use exactly the native Kubernetes API definition. For example, deployment, right? And what the Karmada do is that the system will automatically match the propagation policy. Propagation policy is the kind of scheduling relevant or the placement relevant policy to help dealing with the multi-cluster scheduling stuff. Yeah, and then the resource binding is kind of also a Karmada dedicated object to provide the unified abstraction to help the whole loop driven, and also the override policy is kind of similar to the override field in the Kubernetes Federation to help users specify their configuration customization between different clusters. So we think the most interesting thing is that people can create a very general propagation policy to make it able to match all types of deployment or other workload abstractions. For example, they can set the rule to kind of select on some special label, and the Karmada scheduler will match the resource template and the propagation policy to make the decision to trigger to give the result like I want this application split to 3 parts and running in totally 3 different clusters. Yeah, and also the override policy is kind of reusable among the different resources. So users are able to define kind of their override rules from a cluster or from a cloud perspective. For example, they want to change the image prefix according the cloud provider or according their the topological location. Yeah, so work API is the standard we have discussed in the multi-cluster SIG. It's kind of also a wrapper definition of the underlying exact resource object. Okay, so one of the most useful functionality we're providing inside by the Karmada is the multi-cluster failover. So we know that Karmada is managing the cluster status, and also it can help divide the applications to different parts and running in different clusters. So if any cluster disaster happen, the Karmada control plan will automatically trigger the failover mechanism. And also for the cluster kind of status management, we have the similar mechanism, the taint toleration mechanism. So users are also able to define the application level toleration to have different failover behavior among the different applications. Yeah. And also another big feature we're recently moving forward very quickly is the global resource view. It's kind of also a read-only, unified read-only APIs of all the resources. Especially for the Karmada API server itself, we only store the kind of multi-cluster dedicated and multi-cluster relevant objects like the deployment people want to kind of be managed by the Karmada, and also want it to be splitted or deployed into multiple clusters. But there are more applications or other services running inside the member cluster. So we have the kind of unified storage and the search entry to make people to easily access and query all the underlying member cluster resources. Yeah, so the current implementation, we use the Elasticsearch or database as the backend to store all the resources, and we expose the query and also the exact resourceful API to help users easily access all these resources. Yeah, so actually there are a lot of interesting features going on.
A question about the previous slide. So, so for this global resource view, do users actually have like some sort of user interface, or how do people query this information? Is it through the Elasticsearch interface, or yeah?
Yeah, so actually we actually have the kind of aggregated API server as the entry, so users are able to directly use the Elasticsearch query to search for the resources, and also they can have the exact API path to access an exact API object if he knows the cluster name, namespace, resource kind, and the resource name. Yeah.
So can you query with like kubectl, basically? Is that a with like this is like a custom CRD, right? So you can do like kubectl or registry, or it's basically through like a different mechanism.
Yeah, actually, for if you want to type in the Elasticsearch query, it's like kubectl just forward your query to the through the aggregated API server to the Elasticsearch entry point. Yeah.
Got it. Okay. Thanks.
Yeah, and there are a lot of more interesting features, so I won't go through too much details. And for the community perspective, we think it's have a very good momentum. So currently we have more than 3,000 GitHub stars, and also the contributing member organizations. We have now more than 50, which is quite good increasement comparing to what we have in the when we're entering the sandbox. Yeah, and also one of the mission of the Karmada project is that we want to help help all these end users quickly move and easily move to a multi-cluster, multi-cloud architecture, and also we want to help the other CNCF ecosystem projects to achieve the multi-cloud, multi-cluster architecture. So we currently have 15 adopters. Yeah, and they include the end users like the banks and also the cloud service providers. Yeah, I will go through more details as an example. So currently, the most feedback we got from the users are that one of the benefit is that they don't need to adopt to new APIs. So previously they have like kind of their own business wrapper layer on top of multiple Kubernetes clusters. When they want to have a more robust architecture, they can easily adopt it to Karmada project. They just need to deal with the policy part, which is new APIs. But for the application, for the workload deployment, they can directly go through what they have already. Yeah, and also one of the feedback is that Karmada is a open source project in the CNCF, so they are kind of keen on the neutral of this project. Yeah, and yes.
I just had a quick, but I think this is answered in the next slide. So I was gonna ask if there's some integration with like GitOps tools like Flux, but I think you have it in the next slide anyway. So I'll let you talk and complete. What do you want to say?
Sorry.
My question was mainly going to be around if there are any integrations with GitOps tools like Flux or Argo CD. Like maybe if someone wants to distribute and helm releases in multiple clusters, something like that.
Yes. So the next slide we have this information. So here we actually already integrated with some of the ecosystem projects to help them to achieve better multi-cluster functionality. So for Argo CD, we actually are able to integrate with the Argo CD to provide a multi-cluster resource management, and especially we know that Argo CD itself also provide, but it's kind of splitted or divided management between different clusters, right? So the application can just kind of replicate among the clusters, but Karmada is able to provide like dynamically scheduling the replicas to the different clusters. Yeah, and also we have we also have the user guide of the details. Yeah, and also the Flux is kind of similar. And for also like the security and the governance, we have integrated with OPA and the Kyverno to enforce their unified policy or rule management among multiple clusters to help users save their energy of repetitive management. Yeah, and for the monitoring, it's kind of just aggregating all this metrics data from the member cluster to a unified federation level. Yeah, and also we have integrated with more projects. Yeah, and actually for the service discovery, I think that what Karmada did a lot is that we help improve the MCS API discussed in the Kubernetes multi-cluster SIG, and also simplified the service export and the import loop between clusters, and makes it easier for users to define a unified service among all the cluster resource pools. Yeah, so wherever the applications get scheduled, they can use the unified service name to access the backend pod. Yeah, so here is just some more details about the end user use cases. So I will just pick 3 examples. So one is Vivo. So Vivo is a kind of actually a smartphone producer from China. So their challenge is that they have a large amount of clusters, and they want to achieve kind of a unified application management across the clusters, and also they want to achieve the cluster auto scaling and the scheduling. Yeah, and also the dynamic failover among the clusters. Yeah, so what Karmada made is that actually we have the unified management plan, right? We have the unified Karmada API server to help the users kind of unify the API entry point, and also it's quite easy for the users to unify their identity and authorization. Yeah, and also because we have the multi-cluster scheduling, multi-cluster failover, it's quite easy for users to benefit from these features and also to expose these functionalities to the application teams. Yeah. And another one is the bank. It's ICBC, which is the largest bank from China. So in their environment, they actually have a lot of features, and they actually have around almost 100 clusters, and currently they have kind of adopted a Karmada with more than 50 clusters. And in their use case, actually, they think the Kubernetes cluster itself as one of the failure domain, because any failure of the Kubernetes API server or the kind of stability or bandwidth change of the storage, it will cause it will affect the availability of the applications running on top of that cluster. And also their cluster are located in different data center and a different location. So they just want to a kind of unified layer to deal with that. And actually in the ICBC, they have the kind of platform team and also different team managing their own business applications. They actually want to expose the underlying resource information, like how many clusters we have and where are these clusters and how many resources are available to the business applications team, but they don't want grant too much privilege to the business teams. So with the Armada clusters API, they can just grant the read access to all these member teams, and they can query and kind of customize their application deployment rules to select their preferred availability zones or data centers, like that. Yeah, another one is the China Mobile. So China Mobile is a big telco from China. They also have a large amount of the clusters, so they actually want to use Karmada to help them deal with the limitation of the cluster size. Because they also have a lot of heavy workloads. And there are a lot of stateful applications running in these clusters. Some of them need to communicate with each other. So with the Karmada, it's quite easy to dynamically schedule this different part of the system, their business system, and also with the multi-cluster service mechanism, it's quite easy to help them simplify the cross-cluster service access. Yeah. So that's just some of the example of Karmada adopters. So and also during the past year, we actually working on a lot of interesting features. We also implemented the multi-cluster ingress API, and also we provide the global proxy or kind of the API entry point to help unify the multi-cluster identity, multi-cluster access authorization management, and also we provide the more higher level HA failover mechanism for the applications. And for the scalability perspective, we also made a initial test. So Karmada now support managing 100 clusters with 5,000 nodes each. Yeah, so that's just a brief about the project. And we think today we have already got a lot of user adoption, but we are expecting to make the community more open and beneficial to more users, and as well as the adopters. And also for the Karmada project this year, we think the reliability and the security are the most important because there are a lot of end users already using Karmada to manage very large scale, like 100 clusters or 30, 50 clusters. Yeah. And for the incubation process, we are currently also looking for the TOC sponsor. Yeah. So yeah, that's all about my presentation.
Heba, I think you had some questions in the chat. Do you want to ask them?
Yeah. So actually, of course, you know, like before anything, Karmada is one of the amazing projects. I've been following, you know, like the work for more than a year now, and it's amazing, the effort and the community. So thank you so much for that. And I know it's a really hard problem, and like having like having to put this effort to like to have a good solution for this problem. It's really like fascinating. So thank you so much for that. So I have a question actually regards the cluster upgrade, either for Karmada API or the main cluster, or we can say the host or the master cluster and the members as well. How are we handling that with Karmada? Is there any effect if like the members got like higher version than the API, or vice versa? How you can handle?
Yeah, so currently what we have made is that we actually have a kind of matrix testing for the situation, like the version school between the Karmada control plane and the member clusters. For the compatibility, currently we are actually following the range of the client goal. So so basically the client goal have kind of we know the mechanism and the range to support the version school, whether it's the member cluster have is the higher version, or the control plane is the higher version. Yeah.
Okay, so
did I answer your question?
So I think, yeah, so there is no problem, like if any of them have like a higher version, that will not be a problem. Okay, yeah, thank you. The second question actually is the auto scaling, or HPA. How this will happen again for both the APIs and the members.
Yeah, so for the HPA, actually one of the major idea from the Karmada project, we think the Kubernetes cluster itself is kind of autonomic, right? So it actually can deal a lot of situation already. So from the Karmada perspective, we mainly focus on the situation that a single cluster don't work, or a single cluster is not sufficient. For example, when the cluster is kind of full, lack of the underlying user resources, we can trigger the cross-cluster auto-scaling to provide more instance for the applications. Yeah, but for the if the clusters still have sufficient resource for scaling that application, we will just let the single cluster HPA to deal with that. Yeah, so that's the major idea of the Karmada. Yeah.
Okay, and the last question actually related to the Karmada APIs or API server backup, and and actually the database or the Elasticsearch backup as well. Are we just like like how we can like how we can back up this? Is it like just like multiple zones, or yeah, if you can just like give us an idea about how we can handle the backup, especially for API server, Karmada API server.
Yeah, so actually, currently, the managing the kind of the availability is very similar to how do you deal with the Kubernetes control plane or the Kubernetes API server, because the backend storage is etcd, so making the different API server instances deployed in different AZ is possible, but we also know that there are some limitation due to the network latency for the required by the etcd. Yeah, for the longer term, we are also looking for solutions, for example, to integrate with the Kind project to change the backend storage to like the database, but that's still in the progress. So currently, what users can do is reuse the practice of managing the high availability for the Kubernetes API server.
Thank you so much.
Question about the API server. So that's multiple API servers that are running, they're redundant too, like your Karmada API servers, or just like a single one, or is there like a redundancy there?
Yeah, so you can actually have the multiple instance of the Karmada API server, but the special here, I mean, the difference between Karmada and the previous version of Kubernetes Federation is that Karmada kind of reserved the API server for its own usage. So the Karmada API server, even though it's the same binary or same image with the Kubernetes API server, we are not expecting people to register node here. Because the workload controllers, they are acting for the multi-cluster mechanism.
Yeah, that makes sense. But also, do you have multiple Karmada API servers configured like in a quorum, just like a Q API server that you may have in the control plane? Yeah, got it. Okay. Got it. That makes sense.
So going to your last slide, you mentioned that you were looking for recommendations from TAG-Runtime. Can you elaborate more on like what you're looking for? And I can also talk a little bit more about the TOC part, but first we'll just talk about TAG-Runtime.
Sorry, could you repeat?
Sure. So I was wondering, so you said you were looking for recommendations from TAG-Runtime. So what kind of recommendations are you looking for?
Yeah, so currently it's like I think the next step is that we need to find the TOC sponsor to trigger the kind of the review process of this project, so we can move on for the to the incubation process, right? And also we're looking for the help from the TAG-Runtime to join the due diligence and also the review and the document write-up for the Karmada project.
Yeah, we're happy to review the due diligence, right? So
yeah, and also we actually we already have created the proposal for the incubation application. You might want to take a look. I can send the link.
Open on TOC repo?
Yes, we already opened. Yeah, we already opened the pull request. Yeah.
All right. I was only asking because I was looking at the CNCF TOC meeting notes, and I don't. So there's a section which says projects that are waiting for sponsors, and I don't see Karmada there. So I was wondering if it was open or not. But you might want to get your like the project or the PR added in that list and ping Amy. The TOC Slack.
Yeah, you can also reach out to Amy, or if you need any help, we can also help you up to her. So, yeah.
And from a TOC sponsor perspective, like I'm usually elected to the TOC, but like I'm happy to help out here. But I think the TOC has a freeze in place just before KubeCon that they like don't assign sponsors or just don't take new projects who want to move levels. But if you already have a PR open or just a Google Doc where you can start putting in notes for due diligence, I'm happy to take a look at whoever else on the TOC and maybe TAG-Runtime, Ricardo and others can also just start commenting so that we just have a head start even if we don't start the formal process right away.
Yeah. So the due diligence document, we are still drafting it. Yeah, but the pull request is already there. You might want to take a look first. Yeah.
Yeah, I'll take a look. Thanks.
Can you share the due diligence doc, or have you shared it yet, or have you started it?
We're just starting, so just to put the things together. So yeah, I can share after the meeting.
Makes
Let
sense.
me
Yeah.
try
So
to
yeah,
find.
sounds good. Yeah, I mean,
Yeah.
whenever you feel comfortable, right? So like maybe you feel that it's not quite ready, then we can take a look. I'm going to review it and help you out. Sorry, Nikita. Yeah, you have something to say.
Yeah.
All right. No, I was just gonna say, like, even if it's not ready, you just if you're comfortable with it, you can put the link in the tag runtime channel, and we can start looking at it, or even suggest what sections to add, or basically how you can make it better. So it's completely okay if it's not ready yet.
Yeah. Yeah. Let me share the proposal link first. Yeah. Yeah, I will double check the progress of the due diligence document and share it.
Take your time, no hurry.
Yeah, and also let me send it to the chat window. So yeah, this is the proposal. Currently we have.
Yeah, I can also just ping Amy after this call to add it to the list.
Thank you, Nikita. That would be great.
So are we done here? Or?
Yeah, I think Kevin, are you looking at see if you can share the document, or we can actually do that through Slack channel. Is that okay?
Yeah, I can share the draft version now. Yes, I've just found it. Let me make it public available. Yeah. Yeah, I sent it to the chat window.
Perfect. All right. Thank you. All right. So I think any other final questions? Or?
Yeah. Can you hear me?
Yeah.
Yes.
Yeah. I have a question. I just noticed that in the tag runtime README file, Karmada project can we put Karmada project on the runtime projects list?
I'm sorry. Can you?
Yeah, I think we can. So basically, it's like we think Karmada project it's kind of in the scope of tag runtime, but currently it's not on the list, so we can add. I think we can add it.
Are you talking about on the repo, or what, on the tag runtime repo, or?
Yeah, add the Karmada to the tag runtime README. So there's a section called the scope. There's some example CNCF projects
Yeah.
within the scope of tag runtime. We
Yeah.
can include the Karmada in the list. Yeah.
Yeah, sounds good. Yeah, just create a PR and we can add it.
Mhm.
Oh, okay, thank you.
All right. Well, thank you, Kevin. I mean, this is a lot of work, I think, and so thanks for the Karmada community for putting it all together. And we're looking forward to the next steps and finding a TOC sponsor for incubation.
Thank you.
Thanks. See you next time.
Bye, everyone.
Thank you.
Thank you.
Bye-bye.
Bye.